Now let us see implementation of Boolean function using multiplexer. So consider this example to implement a 4 variable Boolean function f of a, b, c, d is equal to summation of minterms 1, 3, 4, 11, 12, 13, 14, 15. So first of all we draw truth table for this particular function. So this truth table is 4 variable truth table consisting of 16 different combinations of A, B, C, D starting from 0, 0, 0, 0 to 1, 1, 1, 1. Now the output f is 1 for these particular mean terms. So we enter this particular value into this particular truth table. Output is 1 for the min term 1. Min term 1 is 0, 0, 0, 1. Then 3, 4, 11, 12, 13. Okay, so we enter these values. So for 1, 3, 4, and then 11, 12, 13, 14 and 15 the output is 1, and for rest of the inputs the output is 0. So this is how we enter the values into the truth table for the output from this particular function represented in the form of summation of mean terms. The next step is to to pair the rows, to pair the consecutive rows of the truth table. So how these particular rows are paired? The first two rows are paired, next two rows are paired. Okay, so this is how we are pairing the rows of the truth table. Okay, so the pairing is such that in the first pair, if you look into the first pair, the values of ABC they are constant 0, 0, 0 and 0, 0, 0. In the second pair again the values taken by the variables ABC they are same, that is 0, 0, 1, 0, 0, 1. Okay, so this is true for any of this particular pair. For example, this particular pair, the value of ABC it is 1, 0, 1 for both the rows. After pairing this row, then we look at, in each of the pair we look at the relationship between f and d. We look at the relationship between f and d. So if we concentrate on f and d, then we see that f is same as d as far as these two rows are concerned. As far as these two rows are concerned, f is same as d. So we write the expression here, f is equal to d. So f is equal to d is true for the first pair of rows, okay, for which ABC is equal to 0, 0, 0. Okay, now consider the next pair for which ABC is 0, 0, 1. Now again, if you look at the relationship between the value of f and the value of d, then again f, we can write f is same as d. So again we write here f is equal to d. Okay, now if we move to the next two pairs for which the ABC are 0, 1, 0, then the relationship between f and d, it is invert relation. When d is 0, f is 1. When d is 1, f is 0. So we write there f is equal to d bar. Then for the next pair for which ABC is 0, 1, 1, we can see that f is independent of d. Okay, so d may be 0 or d may be 1, f is 0 only. So there we write f is equal to 0. Same is true for the next two pair of rows. So we write f is equal to 0 for that. Then here we see that f is same as d. So again we write here f is equal to d. For next two pairs of row in the truth table, f is independent of d and it is 1, so we write f is equal to 1, and same is true for the last two rows of the truth table, so we write f is equal to 1. So like this we uh, write the expression for the output in terms of either d, or if it is fixed, if it is independent of d, then we write it as either 0 or 1. So your f is either 0 or 1 or d bar, okay, but of course it is true for uh, the pair of rows only. Now from this we write a function table for the multiplexer, okay. So if we take 8 is to 16 is to or 8 is to 1 multiplexer, it will be having three select lines, okay. So we take 8 is to 1 multiplexer, and uh, to that we give the inputs from 000 to 111, okay. So when input is 000, okay, now look at this particular function table. When input is abc, now this s2 s1 s0, we take it as abc, okay. So for first pair of rows it is 000. So what we want output to be when abc are 000, we want output to be d, so we write here d. Then for the next pair of input 001, we want the output to be d, so we write here d, okay. So in this fashion for 010, for 010 we write or we want the output to be d bar. For 011 we want the output to be 0. For 100 output uh, to be 0. For 101 the output should be d. For 110 it should be 1, and for last two pairs, that is 1 when abc is 111, the output should be 1, okay. So we write a function table for the 8 is to 1 multiplexer and the required output for that particular uh, function for that multiplexer, okay. Now this is the function table which we obtained in the last step, okay. Now this is the 8 is to 1 multiplexer. Now 8 is to 1 multiplexer will be having 8 inputs and only one output, whereas there are three select lines for that particular 8 is to 1 multiplexer, and to this three select lines we give the inputs a, b and c, okay. And its input are connected to uh, are connected in this fashion, okay. Zero input or I0 input or 0 input, it is connected to D, rather 0 and 1 input is connected to D. The second input is connected to D bar, okay. Because we want 0 at when the input are 0 1 0, our output should be D bar, so it is connected to D bar. Then for 3 and 4 it is connected to 0. 3 and 4 inputs are connected to 0. Then 5 is connected to input 5 is connected again to D, okay, and 6 and 7 inputs are connected to 1, okay. So in this fashion the inputs of the 8 is to 1 multiplexer are either connected to 0 or 1 or to D or to D bar. Now, if we give input to this particular, if we give now ABCD inputs here, okay. Now, what will be the output here? So, if we consider this particular function table when the ABC are 000, then in that case what will happen? This multiplexer, the ABC, they are S2, S1, S0, they are 000, so it will select the first input and the output will be D, okay. Then when S2, S1, S0 are 001, then the first input will be selected and the output will be D. In the similar fashion, When the input is 0, 1, 0, output will be D bar. When input is 0, 1, 1, the output will be 0. For the next input, which is 1, 0, 0, the output will be again 0. For 1, 0, 1, the output will be D. For 1, 1, 0, the sixth input will be selected and the output will be 1. And for the last input 1, 1, 1, the seventh input will be selected and the output will be 1. So we get the output of this particular uh, multiplexer as per the required truth table. So this is how we can implement a Boolean function using multiplexer. In the so this is the summary of this particular topic, and in the next topic we shall see demultiplexer or decoder